This is a Haas TL tool room lathe. And today we're going to be pretending that it's our very first day with this lathe, and we're going to set up, program, and run this part right here together in this Haas tip of the day. So this is our part. It's a holder for a coaxial indicator. And it has all these steps on it, so it'll fit into our collet chuck or our 3-jaw without having to change out our setup or change out those jaws. Now, I've given mine away and I need one, so this is the part that we're gonna make, and it'll make a great addition for your toolbox as well. The through hole on my part is 3/8 inch diameter because the shank on my indicator is 3/8 of an inch. Now, the shaft on your indicator might be different, so you'll just use a different size drill. And you might want to adjust the size of the steps on the adapter to fit your collets. And that's the beauty of this. You can change everything on this part. You can change the entire shape and make your own part. We're going to make this part out of 3-inch diameter stock cut to 3 inches long, 76.2 millimeters. We're going to turn the first side and drill it, and that's going to be our first operation, operation 10. Then we'll flip the part over, turn the back side, op 20, and then we'll take the part over to our TM, our tool room mill, and we drill and tap it for a set screw. Here's the print that we're going to be using, and it describes all of our lengths and diameters, and we can also use it to describe how our lathe moves. This point here is 0.5 inches, 12.7 millimeters from zero, our center line. But we would never call this point X.5 or X 12.7. The tool at this position is at X 1 inch because it creates a 1-inch diameter at that position. This is a lathe and all of our X values are in diameter. Now let's take this over to the lathe. On all Haas lathes, our Z plus is away from the spindle and our Z minus is towards it. X minus moves are towards our spindle center line and X plus moves are away from our center line. Now here are the tools that we will be mounting in our turret: an OD turning tool, a spot drill, and a drill. When I'm setting up long drills or reams, I may indicate along the length of a ground shaft first, making sure that the holder is straight before fully tightening it down. The lathe needs to know our exact tool and part locations, and these are our tool offsets and our work offsets. Now, to set our tool offsets, we will start by using an indicator to find the X center of our drill holders. Now, once we have found center, front to back, we will highlight the tool offset for that tool, press the X diameter measure button, and enter 0 for our diameter, because we're at X0. Now we'll do this for both of our ER32 drill holders, both tool 2 and tool 3. We can then load up our stock and tighten up that chuck. Now remember, we're kind of pretending that it's our first day here, and if it really was our first day, we'd be telling you to never ever walk away with your T-handle left in the chuck. Really bad idea. It's not safe, and everybody in the shop will make fun of you. On to our turning tool. Now to set the X tool offset for our turning tool, we will skim the outside diameter of our part, jog straight away in the Z positive direction, and then measure our part diameter. With our tool offset highlighted, we will press X diameter measure and enter the diameter value we just measured. To set the Z tool offset for our turning tool, we will skim the Z face of our part and then move straight away in the X axis. With our tool offset still highlighted, we will press the Z face measure button. We now have a clean Z face to set all of our tool Z offsets up against. We will jog our drill up to the face of our part as we slide a shim or a paper between the two, continuing to slowly jog the tool towards the face until the shim drags. With the tool offset highlighted for that drill, we're going to press the Z-face measure button. And that's it. We've set the tool length offset, the Z, for tool 2. We can also subtract the thickness of any shim that we might have used. We'll repeat this process for tool 3, our other drill. For this first operation, we're going to be using work offset G54. So we're going to go to the work offset page, and we're going to make sure that both our X and our Z values are set to 0. On this part, we have to tell the machine where our part is, and that is our work offset. The face of the part and the spindle center line are our X and our Z zeros. That's where we touched off our tools. And that's what we told the machine. Now, if it seems like we covered all of that far too quickly for such an important part of our setup, we agree. That's why we made a complete video on how to manually set our tool and work offsets, and we will link to that video in the description. With our tools and our work offsets set, we can move on to the heart of this video, which is programming our part at the control. To write our program, we'll need some numbers from our print. We'll consolidate all of our X and Z locations to make things easier to read. And now our X, Z values are looking like something we can enter right into the control to create a program. We will add in some lead in and lead out lines to our profile to account for our raw stock, and we'll decide where we want our rough turning operation to start. This is the information that we'll need to program this first operation. You don't know it yet, but we just programmed our first part. Kind of. So close. Now this is a TL lathe, which means it comes standard with VPS, our visual programming system. And that is what we'll be using. We look at the pictures, answer some questions, and the control creates the code. Now for a really simple part where we're just turning the outside of some stock or we're just facing it, we can go to the templates that OD turn or face. For a more complex part with all kinds of steps and chamfers and radius, we will define our profile in Shape Creator. So edit, Shape Creator, and origin for a new shape. And once our profile is fully defined, we will open up that profile back in our VPS template to apply some toolpaths. Let's walk through these questions together. Our raw dimensions define where our raw stock will start. And if we look in the lower corner, we will find expanded instructions for every line to help us out. We'll enter X 3.0 and Z 0.05. Our stock is now defined, showing up on our screen as this green box. Now our rapid point is where our turning tool will rapid to before it starts feeding into the part. Now this point is incredibly important. It defines where our OD roughing starts. Everything below and to the left gets machined, and every move above and to the right of this point are rapids. Now we are going to set our rapid point just outside of our stock. Set it too high and we waste time cutting air. And if we were to set it too low, then our tool will try and remove too much material on those first passes. We're going to enter X 3.1 and Z 0.1. Now something cool happened when we entered these values. The control automatically filled in our Z start position for us. Now that is our contour start position. Now this is one of the most important lathe tips that I can give you, whether you are using VPS or programming by hand. If you are getting alarms when using a roughing cycle, look right there. Look at your rapid point and look at your profile start position and make sure that they share the same Z value position. Now that was kind of a long explanation, but we don't want you frustrated. We want you making parts, which was why we automatically filled in that start Z position. Don't override it, just leave that one where it needs to be. For our X value, we will enter minus 0.062. Wait a second, where did this number come from? I apologize, let me explain. Our turning tool has a radius on the tip of it, 31,000ths of an inch, in this case, about 0.8 millimeters. To clean up the face completely, we need to move the insert below center line by the insert radius amount. And because all of our x values are in diameter, we must go to x minus 62 thou and not just x minus 0.031. No matter what size your tool nose radius is, we need to account for it. For the same program in metric, we would program it to x minus 1.6 to account for a 0.8 millimeter radius on our insert. Now, if we program this particular turning tool to x0, we would end up with a nib or a pip on our part, and it wouldn't fully clean up, which would cause a drill to walk, or it would just leave a pip. This is one reason we should know exactly what insert radius we are using before we even start programming. Now, from here on, we're going to start entering in those XZ locations from our print, adding rows for each new line segment. This start X and Z position is the first point of our contour. X minus 0.062, Z 0.1, the start of our lead-in. To create the second point in our contour, we will add a new row and select linear feed motion. X minus 0.062, Z 0. It filled in the angle for us automatically here. We will leave chamfer and round at 0 because we don't need any chamfer or fillet at this intersection. We'll add another row. Now our third point lands at X 1.0 and Z0. And we do want a chamfer at this corner, so we'll enter 0.02 under chamfer. That's our chamfer size. We'll add another row. The next point, entering X1 Z minus 0.285. No chamfer here. New row. And we will work our way through our contour, entering each XZ point as a new row, a new position in Shape Creator. That is it, our last line segment, our lead out, and we are done. Now we can always go back in and adjust those endpoints or add line segments if we need to. And we can also add in chamfers or radiuses. In fact, that's the way I usually use my Shape Creator. I plot all of my endpoints, and then I go in and I add in my chamfers or my radiuses, just because I like seeing how those things change graphically. Press of the F4 key, and we will name and save this shape. With our shape all saved, we can import that into a VPS template and add our toolpaths. I'll press home and then use the cursor keys to navigate up and over to our VPS OD roughing cycle. Now, this template is good for OD roughing and finishing. And the first question that's going to ask, it's going to ask for a shape. And it says, press enter to select your predefined shape file. And how convenient, we've got one all ready for the task. It defaults to the active tool in the turret, but we can change that if we would like. Now, if the tool we have chosen still has an offset of 0, the template is going to warn us to go set our tool offset. No tool offset present. Please set tool offset to continue. Nothing good can happen if we forget to set our tool offset, and the control is trying to save us from ourselves. Now, we have chosen a legitimate turning tool and offset number, and we'll go ahead and use work offset G54 for this first operation. For our max RPM, we're going to set that to 1,000. Now, this TL lathe, all TL lathes can go much faster than that, but this might be your first part, our first part, so we'll leave it at 1,000. Next, we have our surface speed, and for that information, we're going to go to the products page for the inserts that we're using. These charts give us a reasonable starting depth of cut, feed rate, and surface speed. Now we'll enter 1601. Now that'll give us a really high RPM, but we will never get there because of the max RPM value that we just set for safety. More feed and speed videos to come. Flood coolant, yes please. Stock diameter, 3 inches, and the control got that from our Shape Creator file already for us. Nice. Stock removal cycle, we will choose 71 for OD roughing. Tool nose comp, we will just leave this on, great topic, but for another video. DOC, depth of cut, we'll set to 0.055 inches or 1.5 millimeters. And we got that information from our feed and speed chart. And X finish stock, Z finish stock. We're going to leave those at 10 thou and 3 thou. That's the allowance that we're leaving for our finish pass. Feed rate, we're going to set this to 0.016, 16 thousandths of an inch per revolution. And we might have to come back to this value and bump it up a little bit. I might go to 0.02 to break up those long stringy chips. XZ rapid points, those also came in with our shape creator file. We already filled in that information. And retract home, both X and Z. My template already defaults to no for retract home, X and Z. And you will want to make sure you answer no to these questions as well. Now this is a TL and we are running very long tools, so we do not want to send the turret all the way to the home position before changing tools. Those long tools could hit something. When N, no, is selected, it'll ask us to enter a tool change position. Tool change positions X and Z. Now we'll choose a spot, a reasonable distance in front of our part to do our tool change. We'll choose X 3.1 and Z 8 inches. Z 8 inches in front of our part should be safe because our longest tool is about 5 inches. We will talk more about safe tool positions in a moment. End M code. We're going to leave this as a 1. That's going to put an M1 at the bottom of the program that we're going to be exporting. That's called an optional stop. And we're going to talk more about that in a minute when we run the part. Had we entered 30, it would put an M30 at the end of our code, which tells the control that the program is done and it rewinds the program to the beginning. But we're not done. We're going to be adding more drilling and turning. So for now, M1 is just fine. We are done. That was our last question. And our options at this point are written in this top right-hand corner. We could just close the doors right now and press the cycle start button and it would run that first operation. But that's not our complete program. We have some more operations we'd like to add. So we're not going to press cycle start. Plus we want to verify things. We're going to press the F4 generate G-code button and then select 3, create new program. We're going to place this new program in memory, which is just the main folder on the control. And we're going to fill in the blanks. It's going to ask for an O number, a file name, and a comment. Coax 10 and coax op 10 and press enter. Our new program will show up when we press the list program key. We can select it, and if we want to, we can run it in graphics. And that is it. That is our part. It's running right now, kind of, in graphics world. Now, before we run a real part in the machine with real cutting tools, we want to add in our finish cycle and those drilling operations. For our finishing cycle, we're going to go right back into our VPS template, pressing the edit key, and we're going to go up to our stock removal cycle, except this time we're not going to choose 71 for roughing, we're going to choose 0 for finish. The questions change a little bit, and we're going to enter a new lower feed rate for this finish cycle. And generate that code. I'll press F4, except this time, instead of creating a new program, because we already have a program, we're going to press 1 and insert to clipboard. Now, what just happened there was kind of like what happens when you press Control-C, copy on your computer. It copied it to the clipboard, and it automatically opened up our program in the editor. Now we just have to decide where that new finish pass is going to go. And we want that after the current roughing operation at the end of our program. So we'll press end, and that takes us all the way to the bottom. It's on our clipboard. We'll go to the editor here and press F1. That brings us to our menu. I'll arrow over to paste from clipboard. Select that. And it did it. It added our new finish pass to the bottom of our original program, our 4321 program. We'll repeat that exact same process for our drilling cycles. Again, we're going to get our feed rate from the manufacturer, and we want to be careful here with our retract X home and our retract Z home. We're going to want to answer this question with a big no. We do not want the tools to go home before doing a tool change. So we're going to say no. And again, we're going to set our tool change position Z way out there at 8 inches in front of our part, a nice safe position. We're going to F4 generate code, send this to the clipboard, and add these operations to the bottom of our main program. That is it. We'll run it in graphics here. This whole program written at the control using VPS and Shape Creator. Now, while this is not a video on hand programming, there are some codes that every lathe machinist needs to know and understand. We've written these down in an essential 9 lines document that we'll link to. Before ever programming or setting up a job, we should be looking through the manual and making sure that we understand these basic codes. And beyond this, we can look at that 9 lines document and see what codes we need to be working on next. Back to graphics, and what we are really looking for here are rapid lines that are running right through our part or off in weird directions. If you see something like that, we should stop, single block through our program until we find the problem and correct it. Before we run this program for real, we're going to go into the program and just give our tool offsets and our T numbers one final look. We're going to make sure we didn't make any mistakes. So in memory, I'll press T down arrow. T101, 101 is my turning tool. It is my turning tool. T down arrow again, there's my finish pass. T101, that's good. T down arrow. T202 is my center drill, my spot drill. And that is in fact where I've put it in the turret. And finally, T303 is my long drill. Everything matches up. Well, we've got our program, our tools are all set. We know that they match our program, but as your friend, as someone who really wants to see you succeed, we've got to talk about collision avoidance. A good setup person will make sure that our tools don't bump into anything. And these kind of accidents are prone to happen. They're common in a few key places. Number 1, during a tool change. Number 2, when your tools are way back at the home position, whether it's back towards the tailstock or towards the door. And number 3, when our turning tool is getting really close to these jaws. We are running longer drills, so we do not want to command a tool change when this turret is anywhere near the chuck, our tailstock, or even these doors. We also have to make sure that when our turning tool is at its furthest Z- position, when it's actually cutting the part, that there are no other tools in our turret that can hit these chuck jaws when our turning tool is at its furthest Z- position. And we know from our program, our blueprint, and running things in graphics, that on this particular program, we're going to be going as far as Z- 2.1 inches. We can jog over 2 inches to the left of our face, and we can see that there's nothing here to hit this jaw. But if we had a 4th tool in this turret, say a ream for a more precise center hole, you would really want to place those things carefully so nothing could hit those jaws. Check that out, verify nothing's going to hit before you run your part. Okay, so all of our checks are done. Okay, all of our checks are double done. We can now press the 5% rapid button on the control. We're going to press the single block button, which will allow just one line of code to be run with each push of the cycle start button. We're going to close these doors, and we'll start running this part. We're going to push the cycle start button over and over and over again. We're going to watch our tool, our turning tool, move closer and closer to the part, slowly. And when it's about that far away, about an inch away from the part, 25 millimeters away, we're going to press feed, hold, and stop. We'll then go to the control and look at our position, distance to go values. The distance to go value is how far the machine is going to move if you press that cycle start button one more time. So if it says distance to go, minus 5 inches, but we are only this far away from the part, stop it. Something terrible is going to happen. Because if it moved 5 inches, we would have a problem. Something's gone wrong. We need to stop. We need to check our program, check our offsets, and correct the issue before we proceed. But in this case, We've stopped that far in front of our part. Our numbers look reasonable, so we'll continue. We'll single block through the first few passes of this roughing cycle, and then we could probably turn single block off. The cycle looks safe. We might turn on option stop. We talked about this before. The option stop button, that's going to cause the machine to stop every time there's an M01 in the program. And VPS added that for us after each and every operation. And that's the perfect time to check our coolant, make sure everything's got coolant on it, and make sure there aren't chips wrapped around tools. And because we're saying this might be our first day, you never reach into a machine and remove long stringy chips with your bare hands. They can cut like razor wire. With this first operation done, we're going to flip it over and repeat this entire process on the second side of the part, creating a program, double checking our tool change positions. And for this second operation, we will choose and use G55 in our templates. Now, running a second operation, G55, is explained in the linked lathe offset video that we referred to. To finish up this part, we're going to take it over to the TM mill and we'll drill and tap it for a set screw. That was our TL part walkthrough. I hope you feel a bit more familiar with this versatile machine. Now, I really like the ability to program a part like this right at the control. But for a lot of parts, there is simply no replacement for a modern CAM system. We want you to be successful, and this means becoming confident not only with your machine, but with your CAM system. No matter how we programmed our part, it's always a good idea to go back into our proof program and say so. And if you are running a proof program, then run it at 100% rapid. This is a precision machine. And if it ran fine the first time, it's going to go to the exact same spot every time after that, so let it fly. When you first start up a TL lathe, you will in many cases see a zero return menu like this one. It gives us an option to hand jog to a safe position first before we zero return our tool turret, which will command a tool change automatically. And then we can safely zero return our X and Z axes. If your TL or any Haas mill or lathe really does not have that zero return pop-up menu, we can still safely start things in order if we use a zero return single function instead of the power up key. If we need to jog this turret out of the way before the machine's been honed, we can turn on setting 53, jog without zero return. This allows us to jog to that safe tool change position. It is a good time to mention our bonus content. And if you follow this link right here, and it's also in the description, it'll take you to the bonus content page for all of our videos, where we'll have the blueprints that we use all throughout this video. We'll also link to our Essential 9 Lines video with all those codes needed for the lathe. And we'll also link to our lathe offset video, which really is essential viewing when setting up one of these lathes. Well, that is it for this time. Thank you for letting us be a part of your success and for watching this Haas tool room lathe tip of the day.